Welcome to this brief lecture on how to turn Excel into a simulation tool with about 10 lines of code. And in this lecture, we will work homework 4. Now, Excel has an object model, and many programs have object models that are pretty easy to use once you understand the fundamentals. So in Excel, we have the worksheet object, which is inside of the workbook, which is inside of the application. So one application might have multiple workbooks, and then each workbook will have multiple worksheets. And anything that you can do through the graphic user interface, you can do with programming in Excel. And you can have events that are triggered. You can have properties, things that you set about the object, as well as methods, which are actions the object runs. So, for instance, the worksheet name, the cell values would be examples of properties. And the worksheet object has methods for things like recalculating and spell checking, and the workbook would have methods for saving, etc. Almost everything that a user can be done in the GUI can be done through Visual Basic in Excel. So in this homework, we are going to do a simulation where a series of inputs is put through a complex function. In this case, it's a net present value function, and then we look at one or more outputs. Now, a lot of problems we'd want a closed form solution, a simple equation to describe a system, but often these are difficult to develop, so we resort to simulation. And in this case, the inputs are going to be the cost of the project and the savings from the project each year. And they're not constant values, but random values. And the output of the project will be the net present value. The Excel worksheet object represents a worksheet in Excel. It has lots of functions for mapping and gathering data from the worksheet. And in this exercise, we're going to use calculate to calculate the worksheet, and cell, and the cell sets or gets the value in a particular cell in the ith row, jth column. So let's try to implement this homework. And we want to determine the payback of the following scenarios. The cost of the project is $1 million with a standard deviation of 100,000. So in order to do this project, we have to pay $1 million, and there's some variability with a $100,000 standard deviation. The savings from this project is $100,000 to $200,000 per year with a uniform distribution. And you might not know the exact savings from a project due to variability in demand, as well as how effective the project is. So the cost of the project is obviously random due to unknown factors, and the savings may also be random. And we'll also assume that the savings last 10 years. So the question is this a good project or is this not a good project? And when you take engineering econ, those of you who haven't already taken it, you know how to compute the time value of money, and you'd say $1 million cost versus an annuity stream of $150,000 over 10 years. Is that a good investment? But we want to analyze this with randomness in both the savings as well as the project. So we're going to assume a 10% interest rate, and we're going to compute the mean and standard deviation of return using simulation in Excel. And we're going to answer the question, what is the chance the project loses money? The first step is to set up a worksheet that determines the time value of money or the net present value actually, for the following project. Project cost $1 million with a standard deviation of 100,000. The savings is $100,000 to $200,000 per year, and the project lasts for 10 years. So let's set up a chart with year and 0, 1, all the way to 10. and then we're going to have a column for cash flow. And I know a lot of you probably have not had engineering economic analysis yet, but this is the standard analyses. You put in a cost, and you put in an interest rate, and you determine what the current value of that project is given the interest rate and cost. So the cost of the project is $1 million. So we're going to create a random variable with normal distribution. So do norm inverse, INV, with probability random. So this just generates a random number that has a normal distribution with mean 1 million and standard deviation 100,000. So let me make sure I got that right. 100,000 and a million. And let's go ahead and make this column an accounting column with no decimal places. And each year this project saves us anywhere from $100,000 to $200,000 with a uniform distribution. So you just put 100,000 plus random times 100,000. And a lot of projects are like this, where we don't necessarily know the exact value of the project or the exact cost. And I'm going to put these equations up here so you can see them a little better. I'll put them off to the side, sorry. And this would be a little larger. Okay. Now, in the first year, we actually have to make that a negative number because it cost us money to install the project. I will make it negative here. Apologize for that little error. And fill down. Now, to compute the present value of investing $800,000 and then having this cash flow, what we would do is net present value of that series. So in cell C6, let's enter NPV, which is net present value. The rate is 10%, and the values, we're just going to highlight all of these values. And we'll call this net present value. And so if we hit F9, which recomputes the sheet, we can see that sometimes this project saves money and is beneficial. Sometimes this project costs money. And what we're going to do is write a little program that just does that over and over again to determine what the expected or average cost and value of this project is. Now, the first thing you have to ensure is that you have the Developer tab displayed. And I've already set up Developer on mine. If you don't see Developer on mine, what I want you to do is go back to File, Options, and then go to Customize Ribbon and check Developer right there. And you know, there are a lot of neat things you can do in Excel options. You can set the language. You can add add-ins for things like Solver. You can set rules for saving, proofreading, formulas, etc. So we have Developer tab, and now we're ready to start programming. Now our program is quite simple. What we want to do is we want to copy this value to a different worksheet and then hit F9 to recalculate the sheet, or F8, sorry. And just keep recording that value over and over to determine whether or not the project saves money or not. And it looks like this project does not have a positive net present value. But we'll find out. So I'm going to insert another sheet. And I'm going to put simulation run and net present value. And I'm going to write a program that basically copies from the first worksheet to the second worksheet. And to do that, you go to Developer tab and go to Visual Basic. And in sheet 1, I'm going to write a little subroutine to do this. Let me expand this out here so you guys can see it. And I'll make this more narrow. I'm just going to call it sub-simulate. Doesn't really matter what you call it. So the first step of is to calculate the worksheet. So sheet 1 dot calculate. Sheet 1 is an object, and calculate is a function that the object can do. So sheet 1 dot calculate. And let me zoom in here so you guys can see it at home easier. And you go to options and you can change the font to say 14. Now all I have to do is copy from one sheet to another. Well, that solves one of my problems, but I want to do that 1,000 times. In order to do it 1,000 times, I'll do a for loop and just tab in and say for I equals 1 to 1,000, calculate, and then you end the for loop with next. And so it's going to do whatever's in between 1,000 times with I equal 1, I equal 2, I equal 3, I equal 4, etc. So in sheet 2, cells, and sheet 2 is the object. Dot cells gets the property of the cell in the second row plus I, or I plus 1 row, because we don't want to put it in the first row, we want to put it in I plus 1. First column, I'm just going to put I. And sheet 2 dot cells I plus 1. Second column, I need to put the net present value. Well, the net present value is on the first sheet in row 6, column 3, column C. So that'd be sheet 1 cells row 6, column 3. And I think we're done. Hit run. It'll take a second. And we come back here and we can see it's done it 1,000 times, and it's computed the value in the first sheet, copied the value in this cell into the second sheet. And so what we've done is we've turned Excel into a simulation tool in 3 lines of code. And so, actually 5 lines. A for loop, and you don't have to type the comments. Anything after the apostrophe is a comment. I'm just going to review the code. Recalculate the first sheet. Write the simulation number to the second sheet. Simulation iteration number to sheet 2. Write the okay. And Visual Basic, little programs like this can often be very useful. Let's say you have 500 or 1,000 or 2,000 Excel worksheets that each contain a problem report. And they're all the same format, but you need to put them all together. Well, you just write a program that opened the first worksheet, copy the data into the second worksheet, close the first worksheet, open the second worksheet, copy the data into another worksheet, and then you could get all the data out of the 1,000 worksheets into a tabular format. Now, the final part of the assignment is to compute the mean, or the average, and the standard deviation, average of all those, and standard deviation of the rate of return on the project. And so the mean rate of return on this project is negative $68,000. Now your results may be slightly different than mine. And the standard deviation of return is $100,000. So if you did a normal distribution, it would be negative $68,000, but there'd be still a good chance that you could make money on the project. And so the next part of the question asks, what is the chance the project lose money? I'm going to do count if, and the criteria I'm going to do is less than 0. And the criteria has to be in quotes, sorry. And so we lose money $700 times out of the 1,000 times we ran the simulation. So the probability we lose money we could just estimate as that divided by 1,000, or 74%, 74.1%. Now your number might be 70.2% just because of we are using random variables. And each time you restart Excel, it'll generate different random numbers and the results will be slightly different. Now, to submit this homework, just answer the questions, what is the mean and standard deviation of return using simulation? When I ran my simulation, it's minus 68,000 for the mean return. Standard deviation was about 100,000, and the chance the project lost money was 74%. Just answer those in a quick paragraph, submit that into Blackboard. Do not submit the Excel workbook, given that Blackboard probably won't accept an Excel workbook with a macro. If you remember earlier in our discussions, we talked about how a lot of programs won't allow macros in Excel just because it is a security risk. The purpose of this introduction to programming is just to demonstrate what you can do with Excel programming. I hope you've enjoyed this quick example. We learned how to copy from one page to another, how to do a loop, as well as how to recalculate the worksheet. And with those simple things, we can write our own simulations. If you really need to do an Excel simulation, you might consider looking at software like @Risk, which have some additional features. They'll watch cells and then they'll store it and they'll put it into a neat report for you. But the basic idea is just what we did today. Thank you and have a good day.